Hey guys, this is Mr. Bennett, and I want to start off by saying congrats to period 2. You had the highest average on the second cumulative exam, so I got the mustache going. Hopefully tomorrow I'll be able to kind of form it or wax it into some sort of handlebar mustache, but this is as close as it gets for right now. That said, good job all the other periods. Averages were pretty good, but period 2 did get ahead just a little bit. So anyhow, congrats again to period 2. So this is video 8-1, and we're going to add our third type of bond. We've talked about ionic bonds, we've talked about metallic bonds, now we're going to talk about covalent bonds. So as you saw today in class, covalent compounds are also known as molecules. Okay, so basically any sort of compound, meaning combination of atoms using bonds, that uses a covalent bond is referred to as a molecule. Okay, and the difference between a covalent bond and an ionic bond is that covalent bonds share valence electrons. Ionic bonds, we talked about last unit, we know that they have to do with a transfer or an exchange of electrons, meaning that you have one atom and you have another atom, they trade an electron, so that as this atom loses the electron, right, it becomes positively charged, it becomes a cation, and as this atom gains the electron, it becomes negatively charged, or an anion. Once that occurs, you then have a bond that forms between them as electrostatic force, meaning this positive charge is attracted to this negative charge. The difference is that with ionic compounds, this charge is going to attract other ions. So this positive charge here, while it attracts a negative, right, will also attract other negative charges, right? And so it'll get surrounded by negative charges, and these negatives will attract other positives, just like magnets, right? If they get near other magnets, the opposite charges will attract. So you end up building this giant crystal for ionic compounds just because of that transfer of electrons. In covalent bonds, you're simply sharing, okay? And it happens between two atoms. You will not get this huge buildup of a crystal or a giant, substance through attraction of opposite charges. They simply share to get their octet. The goal is to get to the octet. Once they have it, they're done. The bond has formed, and you won't get these big, huge kind of clumps. The other difference is that ionic compounds occur between metals and nonmetals. So you usually have a metal and a nonmetal. The metal ends up being your cation, your positive charge, and then your nonmetal ends up being your negative charge. In the case of covalent bonds, you typically have two nonmetals. So let me give you an example, and I'm going to use Lewis dot. So just as a refresher, remember with Lewis dot, if we take an element like oxygen, oxygen has 6 valence electrons, so we simply start putting some dots around it. The dots represent the valence electrons. We put one in the top section, one on the right, one underneath, and one on the left. These are the 4 sections where I can put my valence electrons. Oxygen has 6, I've placed 4 so far. Now I go 5, and then 6. So those are my 6 valence electrons. Now, let's say that we want to combine oxygen with a simple atom, something like hydrogen. Okay, hydrogen has 1 valence, so I put my 1 valence here. The other thing about hydrogen that you have to remember is that hydrogen's octet is actually 2 electrons, right? Oxygen, on the other hand, wants that nice, clean, like normal octet of 8 electrons. So if hydrogen can get to 2 electrons, it will be happy, more stable, it will have its octet. And if oxygen can get to 8, it will have its octet. It will be more stable. So what we can do is, instead of doing an ionic exchange, meaning literally just give it away, in this case we can form a covalent bond and we can share. So hydrogen can share its electron with oxygen, and oxygen in turn will share its electron with the hydrogen. So we'll get a little bond formed here. Okay, so this electron will essentially be oxygens as well as hydrogens, and this electron will be hydrogens as well as oxygens. Okay, when we do that, that means that hydrogen now has its octet. It's got 1, 2 electrons. It's happy. Oxygen, on the other hand, right now has 1, 2, 3, 4, 5, 6, 7. So it doesn't have 6 valence electrons anymore. It's got 7. It's closer to an octet, but it's still not there yet. So what can we do? Well, let's bond it with another hydrogen, because let's assume there's another hydrogen nearby that also wants to fill up its octet and be more stable. So we'll form a little bond here. So now this hydrogen has 1, 2 valence electrons, so it has an octet. This oxygen now has 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So it is now happy. It is more stable with its octet. What compound have we formed? Well, there's 2 hydrogens and an oxygen. In other words, this is H2O, or water, right? Water is a molecule. It's held together using covalent bonds. Those covalent bonds are created when the hydrogen shares its electron with the oxygen. And in turn, the oxygen shares its electron with the hydrogen. Okay, so if we draw this a little cleaner in terms of Lewis dot, we would draw it like this. We have our oxygen with its bond to the hydrogen. We have another bond to the other hydrogen. And then notice that the oxygen has 4 electrons that are not involved in bonds. They are what we call lone pairs. So we'd call these guys here and here. These are called lone pairs. They are electrons that belong to oxygen and do not participate in the bonds between the hydrogen and the oxygen. Okay, we'll find out that they have some added kind of effect on the molecule in a future set of notes. Now, to clean this up even more, something we can also do is we can actually connect these 2 dots here, these shared electrons, with a line, and that line will represent the chemical bond formed between them. So the line here actually represents 2 electrons that are participating in a bond between this hydrogen and this oxygen. Same thing here, this line represents 2 electrons shared between the hydrogen and the oxygen. Okay, and we've got our water. So that's what a covalent compound looks like. If this Lewis dot's confusing you a little bit, we'll have more practice tomorrow. You can ask more questions. For now, understand that the lines represent shared electrons between 2 nonmetals, and just like with ionics, the goal was to get to an octet. Okay, so